Welcome, ladies and gentlemen. I'm playing with expensive but not so much now junk again, and here we have the Cisco UCS Unified Computing System from about 2009. For all those who know Cisco only from network products, they also make servers, and in this case blade servers. They look something like that. We have 4 of them in this chassis, which is made to hold 8. But there are also standalone servers and additional devices like the ones on the top here. And of course network, and the whole unified computing system idea is that the computer, the hardware, the network is unified in a mostly virtualized environment, so everything can be changed without changing the software. And well, there are a lot of other videos about that. I just want to show you the hardware side of this stuff, and I want to look inside, and maybe there is something interesting. The system I have here consists, as I said before, of 4 blade servers and 2 FI modules. That stands for Fabric Interconnect. And what they do? Well, they connect to the servers. Here are 8 server ports, and that's another 8 server ports. So it seems that each server has 2 network ports for redundancy. They go to 2 fabric interconnects, also for redundancy. We have 4 here and 4 here. I assume that if I had 8 server blades, I would have to attach all 8 cables, so I have only 4 servers. It seems that 4 cables are enough. So these fabric interconnects here, that's the part number if you are interested in that. They are mainly there to manage the entire computing system here. And there is also the whole management, the web interface where you set up all the stuff here. It's also inside these blue-green boxes. But of course, as always, before I take it apart, I turn it on. Alright, that was the startup sequence, and it was pretty loud, and it got a little bit more silent now. And the loudest device, in fact, are at the moment these fabric interconnects, and they won't get any more silent than that. Okay, then, if all the cables are in the right connections, you can enter the IP address of this management website. The IP address is given through the serial port, like it's usual on Cisco switches. You have a serial console port that works with the famous light blue Cisco cable, and of course an USB adapter to your laptop, and you set the first, how is it called, the first time setup, where you give everything an IP address and the rest you do in the graphical user interface. Let's start that. This is certainly not the newest version, but I think it's also not the oldest version, so we are probably somewhere in between. And if you look in the equipment, topology, let's make that a little bit bigger. We have the two fabric interconnects, and we have our chassis, which is very small here. And it seems that some links here are missing. Gray means all links are up, yellow means some links are down, and red would be all links are down. So maybe it just takes a while until everything is working, because last time when I powered it up, everything worked. So let's see, there is some mark on the chassis one. There is a problem with my servers, it seems so. What's wrong with them? Mismatch identity. Okay. Well, probably I didn't save everything, or it is just discovering still. That takes about 10 minutes or so, and the last time when I shut it off, I probably didn't do that in the right order. So yeah, that's the interface here, and you see the servers, and the problem is it took about 1 day until I was able to turn the servers on. Because first of all, the power button of the server is disabled by default, and that means if you push the power button here, nothing happens. So you first have to set up the user interface. You have to give every server a profile where all the settings are stored. So, and then you're probably able to turn it on from the graphical user interface. And I think I'll have to turn it off because it makes a hell of a noise. But before I turn it off, I want to show you another little toy that is pretty handy, especially if you're a field service engineer and you're working with servers and you need a keyboard video mouse console. So what we have here is, there is a universal plug here in front, and with this adapter cable you get a serial port, 2 USB ports and a standard VGA output. So of course you can connect a monitor, a mouse, a keyboard, and it works. But you probably don't have a monitor, a mouse and a keyboard where you are, and you don't want to take one with you. So there is this adapter, that turns all this into USB, and then you get your console interface here on your laptop screen. And yes, that's the actual VGA output from the server, and I'm currently in this BIOS setup here. Save configuration, yes, and keyboard works, mousepad works, everything works. And the best part is the software is included in the adapter, so when you plug in the adapter you get another USB drive here with the letter E, and if you open that, there are 3 files. There's a Java client that you can use on Linux computers. There is a Windows client, that's what I'm running here on this Windows 10 computer. It's all included, and it works without further licenses or whatever. So if you're interested in an adapter like this, it's from A10 or A10, I don't know, and it's the model CV211, CV211. It's not cheap, so the cheapest version I found, or the cheapest price, is about $200, but yeah, it is absolutely worth it. So if you go to a customer site, you always have your notebook computer with you. You just need this adapter and you're fine. And without any power, it's much more silent. Ah, what a relief. Okay, as I said before, if you want to know more about the UCS system with its software, there are a bunch of other videos with all the details you want to know. There is also the Cisco website where you can download all the manuals for that. It's pretty easy to find and well documented. So let's look at the hardware, because that's the part that they usually leave out, because that's not your work, that's the work of the certified technician. So we have 4 power supplies with 4 individual power connectors on the back side. They are pretty long. And if we look at the label on top of the power supply, we see it's input 200 to 240 volts. So if you live in America with 110 volts, you probably need another power supply, or you need another type of power outlet with, well, 230 volts. I think that exists. We have a total power of 2500 watts per power supply. Of course, with only 4 servers, we never need that much power, but it's always nice to have a little bit of reserve. So the total power with 4 power supply is 10 kilowatts. So keep that in mind if you want one at home. I wouldn't recommend that, it's a little bit silly. Then we have, of course, our 4 blade servers here. As I said, the chassis can take up to 8, and it's the UCS B200 M3. At the moment we are at M5, so that's the generation of these blade servers. And that's how they look. First of all, there is space for 2 hard drives, SAS hard drives, 2 per blade server. You can make a RAID 0 or RAID 1. that's, or have them individually, but that's everything you can do with the hard drives. And because I wanted to install Windows on this server and I didn't have the proper hard drive caddies, I made my own caddies with a piece of tape stuck to the top and the bottom, and then to insert it, it's a little bit of fumbling around, but if you're lucky and you hit the connector, it works. And this of course helps to remove the drives. So that's my trick. Normally you get the proper hardware and there is no problem. The hardware inside the Blade server, well, it's not so special. It looks like any Blade server. It has similarities to those of HP or maybe other manufacturers. We have a lot of space for RAM, although there is not a lot of RAM inside. Let me see, it's 8 GB. So it's 1632 and 2 times is 64 GB. Yes, that's what it was showed in the graphical user interface. Then we have 2 interface cards here. And that's a little bit special. They are not Ethernet, they are not fiber channel, they are both of them, because Cisco here uses a technique that just lets all the traffic, the network traffic, over one connector. So per blade there are 2 connectors, and then later they split that up in a specialized sort of switch into Ethernet ports and into fiber channel ports. But here inside the Blade, these adapters, they do both at the same time. Of course you can have a fiber channel over Ethernet. That means you use the Ethernet protocol and encapsulate fiber channel protocol inside the Ethernet, and you pack it together, you unpack it. Yeah, it's like Christmas. By the way, the processors here are E5 2650, if I remember right. So nothing special about that. Let me see how these cards are attached. It seems there is a large connector here. Yes. So the connector also looks similar to the one that HP uses, and this is the proof that all these hardware manufacturers, they are all cooking with water. No mystery, no wizardry, no magic. If a connector is good, then use that connector. Don't look for another one, and don't make your own specialized connector. It's just expensive, but it doesn't help. Okay, that's the second slot. Okay, you cannot mix the cards. One has the connector like this, the other one like that. Okay, it's clear where which card comes or has to go. Then we have Phillips screws here. Let me get that screwdriver. Okay. 1, 2, 3, and 4. Yes. And that's the processor. I think you know how that looks. I don't have to clean it now. Yeah, the usual socket and everything. Well, that's the blades. Well, just in case you wanted to know the exact number of screws, yes, it's 45. 45 screws only to remove the cover of that fabric interconnect switch thing. And we can clearly see that Cisco is still a network company and maybe not so much a server company, so here is definitively more interesting hardware than inside the blade servers. Let's take a closer look to that. So it pretty much looks like any other Cisco switch. So here we have the front panel or the back panel, depends on which way around you put it in the rack, with the 1, 2, 3, 4, 5, 6, 7, 8, 16, 32 connectors, SFP plus 10 gigabit connectors, goes to these front end chips here. We have DC converters to power the chips. Then we have the main, well, maybe switching chip here, probably something, probably the same chip we will also find in other Cisco high-speed switches. That's most likely the flash module with the software for the switch. So it seems that the switch part here, well, I just call it the switch, maybe, yeah, I'm pretty sure it is some kind of Ethernet or network switch. So this one has its own software here. I don't know how this is updated. Well, you can update everything from the graphical user interface. And then we turn over to the CPU part, and that's probably, well, that's some standard RAM here. Let me see how big they are. Looks like a normal DDR3 low power 10600 registered, 8 gigabyte, and the other one I think it's 2, so we have 16 gigabyte of RAM here inside this interconnect thing. And why I was wondering is when you connect a serial console and you turn this thing on, the first thing you see is an AMI BIOS, American Megatrends Inc. BIOS. They make BIOSes for PCs, so I'm pretty sure there is a normal PC CPU underneath that. Let's see if I'm right. Okay, and that's what was inside. It's an Intel Xeon LC 3528. Never heard of that before. It's a dual core Xeon with a about 1.8 gigahertz of well, speed, and yeah, it's obviously good enough to power this device here. And well, I think most of the work it has to do with the web interface, the graphical user interface. So let's put it back. I think that was already quite an old processor in 2010. There's a date code, copyright 2010. Okay. But everything else would probably be overkill, and overkill doesn't fill your money pocket. Okay, that was a silly word, sorry. And we have another board here which is connected to the main board with a lot of free spaces. I don't know what they planned to do here. There are two interface chips for the rear Ethernet ports. So we have two L1 and L2 ports. They are connected to the L1 and L2 ports of the other device that is used for the clustering, for the data transmission between the two boxes here. Then we have management 0, that's where the graphical user interface comes out. Well, it's a web server. You get an IP address, you take your browser, go to that, log in. And we have, of course, the serial port with the blue cable, something you know if you know Cisco hardware. Okay. Besides of that, there is nothing here. Maybe they plan to have the web server or the web server hardware maybe here, or perhaps there is another board version with chips. I don't know. There is nothing here. So all the magic happens here. And of course we have two power supplies. 750 watts each, redundant, hot pluggable. Yes. Okay, I think that's about it. Well, maybe we have to look at the back side of this unit. We haven't looked at that yet. But I fear there is not too much to see. We have eight, yes, fans, double fans, one fan here, the other fan here. So in fact we have 16 fans with their own interface board there. That's probably to sense the speed and yeah, turn everything on and off. And the other thing we have here is the interconnect that goes to the server blades. Let me see how that works. Okay, yeah, it's just a short module with a large heatsink, so perhaps quite a large processor or a large interface chip. Oh, let's open the box here. There are only two, no, 1, 2, 3, 4, 5, 6, 7, 8 screws more. Okay, that's the server interface board. Battery, large chip, some small chips. I think that's also some kind of a switch. 10 gigabit, of course, 8 times. Maybe a similar chip to the one here, just with, well, less I/O ports or something like that. DC converters, as usual, you make the desired voltage on the board. So the power supplies only deliver 12 volt or whatever voltage, and then all the lower voltages you make here on the board itself. That's more convenient, and if you change any chips, you just change the DC converter and you don't have to change the entire power supply. And if I look at all those screws, I have the suspicion that Mr. Cisco probably has a close relative that owns a screw factory, and they made a deal of somehow, and they said, well, if you produce cabinets, I will supply the screws and we make a big deal. Oh, I mean 40, 50 screws for, yeah, you get it. Okay, that's all for today. Thanks for watching.